Hello. Oh,
Oh, wait a minute. What's going on with
why is that messed
What
up?
happened?
That
what?
was fine
We have
before.
Whoa!
Oh, I know what happened. I know what happened.
I'm voguing.
I know you know what? I minimized his Teams window oh crap. So I could
Ooh.
see it
I think it was better
differently.
before.
Well,
Where
I know it was better before. Hold on. I just have
there
to
we go.
I have to get it.
Puppy dogs.
I have certain parameters set. Why does look, I have a mouse that like the click and drag is like an issue. All right. That's probably what it was for. I shouldn't have fucking.
Gonna be a challenging episode for all of us then.
God, we've already had like some audio issues that we started.
How's it gonna be challenging?
I got two puppies running underneath my feet like they're toddlers with very sharp teeth.
All right. There we go. Whew. Oh my gosh. Well, my mom's made it, and Katie's with us. Yay!
Sweet.
Glad you guys could make it. Yeah, I couldn't hear Brandon. He was like very faint, and all I had to do was jiggle the jack.
I jiggled the jack.
You gotta jiggle the jack. Audio
This
jack. No, on the actual CPU. When in doubt, jiggle the jack. That's the phrase. That's the phrase of the show. Too bad. As we'll see it. We'll see if Jack comes on and
jiggle
the jack.
Jiggle jack.
Jiggle all the jacks. Yeah. It's good to be back. We're last here a couple weeks ago. Seems like it's been a long time. I don't know why.
2 weeks?
2 weeks, yeah. 2 weeks. Oh, Jiggle the Jack's here! Jiggle the Jack!
You're gonna have to tell him the story because
there's context there.
If you didn't hear Jack, audio issues, I had to jiggle the headphone jack on the computer, so phrase of the show is Jiggle the Jack.
Jiggle Jack.
But he's stirring raspberry chili. Ooh, that sounds nice. Raspberry chili.
Yeah, you're the cook in the house.
I don't know. It sounds good. We did ribs last night with Mike's vinegar sauce, and I marinated them in the vinegar sauce for like tasty? 24 hours. It was good. It was good.
Your mom could not handle it.
No. It was like you got the taste of the vinegar sauce, but then it's like the heat builds, so it's like you get through a couple ribs, and then you start feeling like where you're not sweating, but you feel like you're starting.
Nice.
Like
she did mention that.
I was like, I'm not physically sweating yet, but I feel that that feeling of sweating.
I'm going to be getting a grill soon, so I'm going to ask for some Mike George secret sauce.
Yeah.
Well, we had talked about just the other day after I'd made it, actually canning it, and so that like
I'll be your first customer.
Yeah. You could sell it. I don't know what goes into the food.
Yeah, I don't think we can legally sell it, but
food licensing. I don't know. People sell homemade stuff all the time.
Yeah, but I bet they have some sort of. Anyway, we could look into
farmers market.
But yeah, I could.
Oh, Jack.
Do it up.
Oh my gosh!
How dare you?
Shredded roast beef soaked overnight in raspberry juice with chili powder.
Getting the vapors.
God, sounds so good, and I'm so full still from last night, but also from
lunch,
the big sandwich I had.
For
lunch. I haven't eaten yet. I got these. We got shots coming up, so I'm gonna be tipsy ordering something. I'm sure. Yeah.
All right. Well, let's get this party started then. Brandon, count me in.
And 5, 4.
Hey everyone, welcome to another edition of Cosmos with Cosmos. I'm Liz.
I'm Mike.
I'm Brandon.
And we got a high in the sky for May of the year 2026.
Yeah.
Man, what a year, Summer. What a year.
It's crazy, and it's crazy that this is the last year.
It's the last year.
Right? It's just the last year.
It's just the last year.
I mean, yeah. Yeah.
And to get through this last year, what are you drinking, Mike?
Buckyballs in space. I just wanted to do that.
Buckyballs in space.
Yeah. So it's just peach juice with cinnamon whiskey.
Oh.
But I also put in little sparkles, and those sparkles represent the Buckyballs.
Oh, that's
cool.
cute.
We like that.
Wait, I thought you were gonna use that peach lemonade vodka you got.
No, I decided to go to cinnamon because I figured that I would have done it if I did tea.
Oh, okay.
But I decided I wanted like a peach cobbler kind of thing. But I didn't want to add like a vanilla vodka because I thought that'd be too much might compete too much with the cinnamon whiskey. So
okay, all right.
It's like a pared down peach cobbler kind of thing. But
such a mixologist over here.
No, but ever since I looked at the outline and I saw buckyballs, I was like, I'm putting glitter in there. They're gonna be the buckyballs. I'm gonna represent some shit.
I like that. Brandon, what do you got?
Well, for me, it's time to do the Euclid space warp again.
Yeah.
Which is just a mighty mango and vodka.
Ooh, nice,
vodka.
nice.
Vodka.
I got
straight vodka. Regular vodka, or
regular vodka.
Yeah, God, I can't drink the sugary stuff. It makes me all red. Makes me turn all red.
Makes my tummy bubble in the wrong ways.
I'm drinking some Dionysus juice, which technically should be wine because Dionysus was god of wine, but also the party. So I'm gonna include all alcohol into the Dionysus juice. But this is just a Kentucky bourbon peach tea, so it's just bourbon,
it's
peach
Katie's
iced
drink.
tea.
It's Katie's drink. You can thank Katie for this.
Whatever
drink.
else, I know.
Yeah, it's a bourbon. Peach liqueur, so peach schnapps, peach tea, brown sugar, lemon juice.
I wanted something refreshing, and so this is refreshing.
But
very
Katie,
refreshing drink.
Peach lemonade vodka, Smirnoff makes it. I just stumbled upon it at our little liquor store here yesterday or whenever it was,
But Katie and Adam have some boba tea today. I like some boba tea. Boba tea's good. Anyway, if you want to, find out what we're drinking or what we're talking about or space news or whatever, follow us on all the things at Cosmos to Cosmos or Drinking Cosmos on Twitter.
Like and subscribe.
It helps
on
the
algorithm
and on
really
the Spotify's. Apparently, the audio on Apple Podcasts is crap, so don't listen on Apple Podcasts, but listen everywhere else and follow us there, and then also check out our mini episodes, shot-sized episodes called The Shot, out every other Wednesday, just a short form media on astronomy topics, so check those out. Also check out some of our friends, Wildixia, Wildixia on Etsy, and our good buddy Mr. Ron Proctor at the MrProctorShow.com. Also, you can check out, down to Kit Peak in Tucson at the NOR. He works for the NOR lab, does some visualization stuff for them. So you can check that out. And also, our good buddy Jack over in Council Bluffs, Iowa at the Rolling Bluffs Planetarium, rollingbluffsplanetarium.com.
Brandon's going to lose his headphones.
I know, he's got dogs.
Scarlett's going to
he's got dogs galore over there.
I got... Hey! What's that?
Okay. Every time Brandon has to deal with dogs, take a drink.
Is that the secret?
Always.
So here's the thing. Frodo loves his toys. Scarlett doesn't care about toys unless Frodo wants it. So now Scarlett is taking the toys from Frodo, and Frodo's now fighting directly underneath me.
Oh, dogs. You know what? The world is a better place with dogs. It's more expensive if you own dogs because, they like to just make up random medical emergencies that have you go to the vet and spend a lot of money. But, at the end of the day, they're worth it. So if we are nerdy and do make any kind of Lord of the Rings or Star Wars references, then take a drink. But if you want to take a drink every time Brandon has to deal with some dogs, then that is your cross to bear, and have fun if you're drinking actual alcohol along with us and not, something like a regular drink.
You're going to be out of drinks in like 5 minutes.
Yeah.
Ready to go. Let's do this.
All right. Let's get high in the sky for 2026 of May. May of 2026, the 5th month of 2026. We're not quite there yet as of recording this, but when this episode comes out officially, not the live episode, but the cut episode, it'll be May. It'll be May.
It's just crazy how time works.
Check out our episode on time. All right, well, our constellation highlight of May is Corona Borealis.
The Northern Crown.
Northern Crown, to celebrate.
It did it. It finally got on the show.
It did. It
It made it.
It did. To celebrate America's return into a monarchy. We are featuring.
You know what? A monarchy would be nice.
A monarchy would be nice comparatively to the oligarchy, but anyway.
And the dictatorship.
So Corona Borealis, meaning the Northern Crown. You may have heard the term Borealis in relation to the aurora. So Borealis being, northern, whereas Australis being southern, which... if you think about Australia, I guess Australia just means what? Southern land? I don't know.
Southern penal colony?
Yeah. So the Northern Crown, and it's near the constellations of Bootes and Hercules. It's a tiny constellation, but very, very, it's a bright constellation. I would say it's noticeable in a light polluted area, I think. And it looks like a little U or, the shape of like a tiara. Crowns are usually a full circle, right? Because they're like a full head thing.
Yeah.
So really, it's kind of like
tiara is like a big U, right?
Well, it depends. Yeah. You can have one that's just like a headband type of a tiara.
Why are you starting at the back of the head?
It's like
me?
Yeah, it goes like
Well, sometimes it depends.
Yeah, you're starting back here.
It's like wearing your hat backwards, like I often do, because I'm a cool kid.
You're cool.
It's I wore my tiara backwards.
We should have gotten little tiaras to wear for this.
I saw a girl yesterday. All right, so they had like Uptown, Oak Ridge had the Uptown revitalization thing, and there was this girl that was just sweeping.
Oh, they're doing the cleaning, yeah.
Yeah, she was wearing a tiara, and I was like,
maybe she was like
nice.
The
birthday
prom queen or something. Or the tree planting. It's in combination with the tree planting festival that we have here. Queen? So maybe there's like I think they do like something like that. I don't know.
I always wear my crown when I'm sweeping.
Well, you gotta look fancy. Why not? Why not? It's a glamorous job. There are 7 stars that make up the U shape of the crown or whatnot. This is Katie's birth month, so yeah, she should have a tiara. And the stars that make up Corona Borealis that we can see, of course, there's more stars there in the actual boundaries of the constellations, but what we signify as the constellation are those main 7 stars that we see, and they're mostly binaries, like most of the stars in the sky. Alpha Coronae Borealis, or Alphecca, which I'm definitely not pronouncing correctly, an Arabic word.
That
Alphecca,
seems like really close to being problematic.
Alphecca.
See, now we gotta bleep that.
It's a blue-white star, eclipsing binary, so there's a white main sequence star and a yellow main sequence star. Main sequence being that these are stars that are kind of in the prime of their lives. They haven't started to die yet. Yeah.
Oh, I've definitely started dying. Wait a minute.
Yeah, once you get past 35, it's a little downward slope. So, and they're both the white main sequence and the yellow sequence star. They're both a little larger and a little smaller than the sun, respectively.
White one being a little larger?
Yeah, that's why I said respectively, because I did it in order of the way I said, yeah. And they have a 17.4 day orbit, so they're zipping around each other.
They're relatively close.
Zippity-doo-dying around each other. And the white main sequence star is surrounded by a debris disk that goes out to about 60 AUs. 1 AU is 93 million miles, the distance between the Earth and the Sun.
So they're separated by 60?
No, the dust disk around the white main sequence goes out to about 60 AU.
Why doesn't the distance between the other star mess with that disk?
I'm sure it goes through the disk. It goes through the disk of debris. But it's like, just like dust and shit. This pair is 75 light years away from us. Oh, and the eclipsing binary is that the one star eclipses the other star from our viewpoint, right? Right? I think so.
That would make sense. Yeah.
Yeah. Okay. Thank you. The next one in the I don't think I do all 7 of them, but Beta Corona Borealis, or Nusakan, another binary about 112 light years away with a 10 AU apart. 10
Okay.
astronomical units, and they orbit every 10 and a half years.
That's a happy ratio.
Yeah.
10 AU, 10 years.
I know, that's fun. It's nice.
Yeah, the first one,
Yeah.
Alpha, 0.2 AU. I don't know if you said that.
No, I didn't. 0.2.
Yeah, they're separated by a point. It's well within Mercury's orbit.
Yeah, so they're fucking close.
They're close.
They're
yeah.
close.
It's half Mercury's orbit.
And then Sigma Coronae Borealis, no fancy name here. It's actually a multiple star system, so more than a binary star system. So there are 2 stars that are as massive as the sun that orbit each other every 1.14 days.
All right, so pretty
So
close.
they're
That's even
real
closer.
fucking close.
No, that's even closer.
2 stars massive as the sun. Then you have another sun-like star that orbits that pair every 726 years, so way further out from those. And then there's a binary red dwarf system that's 14,000 astronomical units from the other 3.
Okay.
So it's like you have 2 stars in orbit, and then you got another star orbiting that, and then you have another 2 stars that are orbiting all of the above. Fucking stars are fucking crazy. Stars be wild. And then we have some variable stars in the constellation. Variable stars meaning that their luminosity varies. It changes over time. So one of them is T Coronae Borealis. It's a binary star that's a red giant and a white dwarf. So a red giant is a star that is, it has moved off the main sequence. It's exhausting its fuel. Its outer layers have begun to expand off the core. The white dwarf is basically what our sun will turn into once it dies, once it stops being able to do nuclear fusion. And it goes through the red giant stage, leaving the white dwarf behind. They have an 8-month orbit, so pretty quick, pretty close together. And this system is known as a blaze star. It's a cataclysmic variable star.
Okay.
So it irregularly increases in brightness like a ton, and then that brightness drops back down. So it's like bright. Okay, back to normal. That's what it does. That's every time I don't know, I was going to make like a Star is Born joke, but a star isn't being born here, so it would be not scientifically accurate. So it's typically around a magnitude 10. Now, the larger the magnitude number, the dimmer it is. I know, doesn't make sense. We would think that like bigger would be brighter, or the bigger the number, the brighter it is. But no, that's not how it works. It's opposite.
Yeah, and you can only see down to 7 at a very dark location.
Yeah. So it's normally a magnitude 10, so it's dim. But then it can brighten to a magnitude 2 in hours.
And then go back down really quick.
And then go back down to 10 really quick. And this is due to a recurrent novae. Novae.
Okay.
So it's basically got just like explosions happening on its fucking surface.
Probably due to the
because the white dwarf and the red giant are so close that there's probably it's due like that red giant's doing shit to the white dwarf or something. I don't know.
Some vampire shenanigans.
I didn't dig
How
into
often
it too
does
deep.
This nova happen?
It's irregular.
It is irregular.
Yeah. So whenever it feels like it.
We're gonna look into this.
Whenever it gets too hot.
That seems okay. I mean, it must be pulling. Okay.
So the white dwarf accretes matter from the red giant,
and then it goes boom on the surface a little bit.
Or as Wikipedia just called it, the red giant is the donor.
The donor. The donor of material.
Yes.
Okay.
Jeez, okay.
All
right.
Another variable star is R Coronae Borealis. This is a yellow-hued variable supergiant star.
Your sister has a question.
Oh, yes. Do you know why the lower number is brighter and why the scale is opposite to what we think? Because astronomers are mean.
No, it was a great guy. It was a great guy. I think he was Greek, and I can't remember his name. He just wanted to, do them.
It's like those people that play video games inverted, and then you take their controller, and then you're like, oh, what the fuck is this shit?
So, I mean, for the most part, astronomy names make sense, but yeah, the magnitudes are weird. Population 3, 2, and 1 stars are kind of weird. So
there's some weird shit out there. So
leave it.
basically, because some dude decided that, and that's what it is now.
Pretty much, yeah. I mean,
it's pretty much usually how it is.
I wonder if it has to do with you're sitting outside,
Mm-hmm.
and as the stars come out,
Mm-hmm.
these are the first ones I see.
Uh-huh.
So Vega. So then that's
okay.
like
So it's like a
magnitude
1.
and then
Okay.
blah blah blah.
Okay. Yeah.
I wonder
you're
if
counting.
it was something kind of like that.
Yeah.
And then he just kind of more formalized it.
Yeah.
Eventually, and now we're kind of stuck with it. And so you can actually get things that are in negative numbers. So like the sun is -26, which is a shit ton obviously brighter than everything
don't
else.
look at that one.
Yeah. And it's not linear. It's logarithmic.
So it's exponential?
Yeah, it's exponential.
Yeah.
So so like 1 is 10 times brighter than 2.
Yeah, okay.
So forth and so on. Oh, you want me to shut up? All right, got it.
No,
continue.
No, I get it. All right, so back to our Corona Borealis, yellow-hued variable supergiant star. 7,000 light years away, and its brightness drops and increases over several months, so not like mere hours like the other one. And this is due to dust that is basically ejected from the star, dims it. So it has basically like it's solar wind, it's like material is blasting off of it and shit, and that extends about 2,000 AU from the star, so quite a distance. And so that dust, as it's being ejected out, dims the brightness a bit, and then it returns to normal, and then it's like it coughs up some more, it hacks up some more, and then it dims. So
for perspective, Pluto, when it was a planet, was the most distant planet, and its average is 40 AU. So this is what, 50 times that?
Yeah,
it's 50 times the distance between the
sun
and Pluto is way far.
It's way far. That's a large dust disk. Debris
it's
disk.
Like Oort cloud territory.
But it's a big star.
How far is Voyager in AU? Go ahead.
I'll let you think about that while I get into the deep sky of Corona Borealis. The deep sky. There's some exoplanets. I'm not going to go in depth about the exoplanets, but there are exoplanets confirmed in 5 star systems within this constellation. All are large, and all are basically large hot Jupiters.
I also love the fact that we're at the point where, there are some exoplanets. We're not going to talk about it. Whereas this is like 10 years ago, like, holy fucking shit, there are exoplanets.
I know, there's like, what, over 6,000 confirmed now?
Yeah, but you have a story later about how that could explode. Voyager 1 is 172 to 173 AU out.
Oh my gosh.
So this is like even further than that.
I mean, you would think that 2,000 AUs gets close to light year distances, no? Or should we switch to light years? Like, why are we using such a big AU number?
I think we're at like maybe 25 light hours away from the sun now. For Voyager.
Oh, for Voyager, yeah.
Yeah.
Oh, it's 63,241 AU.
Okay, so we're not in light year territory. That's why it's 2,000 AUs. It's still pretty far out there.
From our perspectives, yeah.
So 5 star systems in the constellation have exoplanets, large hot Jupiters out there. Then we have NGC 6085 and 6086.
My favorite.
These are 2 galaxies. The first one is a spiral, and the second one is an elliptical that can be seen in the same telescopic field of view. So they're not together. They're not like interacting with each other or anything. You just can see them both at the same time. NGC 6085 and 6086. So I thought that was cool. You can see them in the same field of view when you look at them through a telescope. And then we have Abell 2142, or Abell, Abell is how that is spelled, and however you choose to pronounce that. This is a huge galaxy cluster, 6 million light years in diameter, and I have asked our fancy physics punk to do some skittle math for this. So that means...
She thought I wasn't going to read the notes and see that.
No, I knew. That's why I put it in red and in capitals. Okay, so 60 million light year diameter. That is 70.6 trillion quadrillion skittles times 4.
Yeah. So quadrillion. I see. I thought I was going to end up reading
a
it.
quadrillion, if you will.
Yeah, so it is
70.6 trillion, quadrillion,
quadrillion Skittles.
Skittles.
It's a lot.
Wow. Okay.
All right, so the next one is like how long it would take to produce that. At 200 million Skittles a day, which is the average Skittle production of the candy company. So it is 7 times 10 to the 52 times the age of the universe. 7 times 10 to the 52
times 13.8 billion years.
Yes, yeah. That's how long it would take.
That's a long
to
time.
produce all the Skittles that can fill that volume. And then I did the straight line across.
That's half a Google.
Yeah. Yeah.
And the straight line across of Skittles. Oh, check. Oh, he blew out the microphone there. He got it. A linear line of Skittles
across the 6 million light years.
Across 6 million light years would be 4.7304 trillion Skittles. And then the amount to produce that would be 4,692.4 times the age of the universe. 13.8 billion years. Holy shit.
Yeah.
It's a lot of Skittles.
You wanted some Skittles.
That's fucking tasting the rainbow right there. And this huge galaxy cluster is 1.2 billion light years away.
Is that really too many Skittles?
As Katie says, I would agree. Yes, that's maybe too many Skittles.
I don't think it is.
Well, it's definitely bad for your teeth.
Oh, there'll be no teeth.
If you don't want any.
How long does it take to eat that many Skittles?
A long
Well, let's see. We could probably eat a Skittle in like half a second, right?
Yeah.
But now, do we involve chewing it or are we swallowing it like an aspirin?
No, you should chew it. I don't think you should swallow it whole. But although, if you swallow it whole, does it come out whole?
No,
there's only one way for science.
One way to find out.
No, but can you then
like
somebody who's like eating a bunch of Skittles whole shake them and make give them a little shake sound?
Rattle. They start guess, and then you play guess the jar of Skittles, but guess how many Skittles are in this person by shaking
Is it
them.
18 quadrillion? I'm just imagining like your shirt, Pac-Man, going down Skittles.
I know, right?
But it's just like me.
Oh, I should have grabbed the cornbread that I made yesterday because we cut like a triangle out of it,
did, yeah.
So it looks like a big Pac-Man head, but cornbread. Oh, Adam can do it. Adam can eat all the Skittles. All right, next we have RX J1532.9 plus 3021. Why these names? Why these names of things?
Aren't they associated with coordinates?
Yeah, they're associated with coordinates and like times that they were discovered or days or whatever. I don't know. But it's a galaxy cluster that's 3.9 billion light years away. And at the center of this is a large elliptical galaxy with one of the largest black holes ever discovered. And a bunch of galaxy clusters. No, because I didn't look it up. A bunch of galaxy clusters in this direction form what's known as the Corona Borealis supercluster of galaxies. It's fucking galaxies all the way down.
I appreciate that Mike. I appreciate that Mike hears black holes. Like, no, we need this. We need to learn more about this one black hole. We must.
Information. I mean, it's going to be a supermassive black hole.
Yeah,
that's real big.
There's some spin and charge involved.
Although with it being in an elliptical galaxy, I'm assuming it's not munching away actively at the moment.
Probably not. No, it's probably
anymore. It's probably it's retired. It's fed enough. It's just going to live out its Hawking radiation days for the next trillions of years.
Oh, it's for the next eternity.
Yeah. All right, now of course with constellations, there's mythology with a good chunk of them, at least in the northern hemisphere. And I will start it off with the classics, the Greeks, with the mythology. And there's different ones, but I just picked out basically the main one here that has to do with Theseus and the Minotaur, aka Bullman of myth. This is a primary story. So a crown was given to Ariadne, the daughter of Minos from Crete, by Dionysus. Hey, god of wine and the party. And this was after being abandoned by Theseus to go, fight the fucking Minotaur and shit. So Ariadne marries Dionysus, and he places the crown into the heavens to commemorate the wedding.
It was an ultramassive black hole.
Was it ultramassive black hole?
10 billion solar masses.
10 billion solar masses in that black hole?
I'm sorry. Continue the story. I'm sorry.
At 10
Yeah, but black holes, they get me excited. I like black
10
holes.
billion solar masses?
Mm.
Okay. Anyway. What was the episode that we just did that me and Brandon's brains
Into
melted?
primordial black holes?
Primordial black
Oh,
holes?
God.
This
Yeah.
is not a primordial black
No.
hole.
My brain is still goopy from that one.
Yeah. So in Mesopotamia, this constellation of Corona Borealis was known as goddess. It was the goddess Nanaya, which is the
Nanaya.
love goddess.
Okay.
Goddess of love in Mesopotamia. Now, this is interesting. We don't normally find constellations with any Welsh mythology. But this one has some Welsh mythological
A wealth
backgrounds.
of Welsh.
It's known as, and my apologies to all of Wales.
Say it with confidence.
Caer Arianrhod, the castle of the Silver Circle. It was the heavenly home of Lady Arianrhod, who is a figure in Welsh mythology. And yeah, there was this whole thing, and I was like, I don't know what any of these things are, so I'm just gonna leave it at that. In there, so that's cool. In Arabic, it was known as Alpheka. Sound familiar? Now the name of the alpha star in the constellation, but Alpheka means separated / broken up. So to them it was like resembled a loose string of jewels or a broken dish.
So we could we can make it the broken necklace of Martha Wayne when her necklace gets ripped off in the Batman universe.
Oh, okay, yes. When she's shot, and then little Brucey has childhood trauma that turns him into a vigilante.
Did nobody think to get him some counseling?
Yeah, Alfred. What more do you need?
Yeah, you can't have good superheroes who are
stiff upper lip. Come on.
Yeah,
you're not British.
I mean, parents just grow on trees. That's fine.
Let's name any well-adjusted superhero or villain. I mean, well, I guess the point of being a supervillain is you're not well-adjusted, but any well-adjusted superhero.
Tony Stark's well-adjusted.
Yeah. Okay. Okay. Continuing on with the myths. The Skeety tribe.
Samwise Gamgee was he's a superhero. He's well-adjusted.
Not in the normal superhero fashion.
I mean, I guess Aragorn, if we're going that route.
Was he though?
Oh yeah, he had his head on straight.
How long did it take him to fucking step up? And be
that's you going through movies.
Yeah, book a movie. The book it would have taken. He's ready to go.
Oh, okay, all right. Well, the Skeety tribe of North America
take a drink.
As the council. Oh, right, Lord of the Rings. Oh shit, I gotta press a button. The Council of Stars, and the chief was Polaris. No.
I'm sorry, the Council of Stars is so fucking cool.
The Council of Stars, and the
That's
chief
a cool
was
name.
Polaris. I know, Council of Stars. Sounds fun. The Shawnee saw them as the Heavenly Sisters who came down from the sky to dance every night, which I enjoy. And then the Australian Aboriginal culture, it was Woomera, which equals, I say equal because I put an equal sign in here for shorthand, but it means boomerang. Which makes sense.
Okay.
Yeah, because it's tiara shapes.
Yeah, it's a boomerang, Woomera, mate. No, that was bad. G'day, mate. Woomera.
Which is not Aboriginally.
I was gonna say.
Oh, that's true. I apologize. But Australian accents are fun to try to do. Same with New Kiwi ones. They're fun to do. They're very hard, though. Anyway. That's Corona Borealis, and it's kind of in that direction of the sky. But you know what? The sky is a big fucking place with lots of shit out there, like planets.
What else is up there? Hey,
some planets. My note for Mercury is just LOL.
I guess you could see with Mercury, Godspeed.
Hey. Yeah, you're not gonna see Mercury. It's gonna be too low. But Mars, in mid-month of May, it'll be low in the east, about 45 minutes-ish before sunrise. Venus will also be low in the sky, but in the western side of the sky. But it will be getting higher throughout the month, so its visibility in the evening will be increasing.
All right.
Earlier and earlier, so you don't have to, you'll be able to see it earlier.
As the month goes by, you'll be able to see it better.
Check out our episode on time and how time works. Jupiter, it's getting low in the west, and opposite of Venus, it's going to get lower every day throughout the month. So it'll eventually disappear from the nighttime sky for a bit. But we've had Jupiter up for a few months now, for several months. It's been up and shining brightly. So if you haven't had a chance to check out Jupes, now is your last chance to do it before it takes a little nap from the nighttime sky for a little bit. Saturn, mid-month, it'll be low in the east, hanging out with Mars. Again, about 45 minutes-ish before sunrise. And then Uranus and Neptune, you need some binoculars or a telescope to see those. Uranus sets around midnight, and Neptune will be visible in the early morning eastern sky. But again, good binos or a telescope. A telescope will help you see them. We do have a couple. Well, we just really have moon events. We have moon events. May 1st. And
just the moon doing normal moon things.
Yeah, the moon's just mooning. It's just mooning. It's just mooning away. Not being pestered by any humans this month. They've all safely returned home. But on May 1st was the full moon, known as the flower moon, because, flowers are coming out now.
Spring is in the air.
Spring is in the air. The 16th of May is the new moon. So that's your best time to look at shit in the sky because it's dark and you don't have the moon.
Unless you want to see the moon.
Unless you want to see the moon. That's not a good time to see the moon. And then May 31st, bam, another full moon. Bam. Which means it's a blue moon. Woo! Because it's the second full moon in a month. Is this the first blue moon of the year?
Yeah, so blue moons only occur about once every 2.5 years. That's about their cadence.
But didn't we have 3 last year?
That seems.
I feel like last year there was a weird amount.
Well,
a crazy
we had
amount
a lot
of blue moons.
Yeah, I remember you highlighting a lot of different types of moons last year.
Maybe it was super moons, but I swear I feel like we had a lot of blue moons last year. Mike's looking it up, but anyway. So double full moon in May. The moon not actually going to turn blue. I say this every time. It's just a phrase that means it's a rare occurrence. Okay, he hasn't found it yet. Oh, God damn it. I forgot to write down this month in astronomy history section again. All right, well. Oh, wait. We do have Meteor Shower Watch 2026.
The last one was August 19th, 2024.
Okay, just kidding. Then.
Oh, about 2.5 years ago.
That was a while ago. Okay. All right, so I take that back.
Yeah, there's one in 2026, one in 2027, 28, 29, 31, and 32. The one in 2028 is New Year's Eve.
Oh, wow.
So.
That's fun.
Yep.
Okay, cool. All right, my memory. It must have been supermoons then. That's what I'm confusing. But we do have a meteor shower in May. The Eta Aquarids. They peak on May 5th through 7th, so the evening of May 6th, basically, middle of the night. And they are actually ongoing from April 19th through May 28th. So they are going on right now. It's just that the peak, meaning the most you can, are going to see, is going to be in the wee hours between May 6th and May 7th. In the southern hemisphere, you can see about 60 per hour. In the northern hemisphere, you can see about half that at 30 per hour. And the debris comes from Comet Halley.
Oh, okay.
Yeah. Unfortunately, we will have a waning gibbous moon because it's so close to after a full moon. So the moon is coming out of its full phase into that waning gibbous. And so that'll hinder visibility a little bit of those meteors. But still go outside if you, want, and just relax out there and just lay down and look at the sky and see what you can see. Mm-hmm. Make lots of wishes.
Yeah, just don't look up. Just lay back, because if you just go out and stand and look up, you can hurt your neck.
You know what this is? If people want us to stand and hurt their necks, you know what? They'll have to learn. They have to learn.
It's just best if you
they'll
back.
Learn a lesson. Yeah, just get a lounge chair.
That's why I've invented the head looker upper device. So it's a big giant pole with a pillow on the end. You just stick it in the ground, look up. But it's supported by the pillow on the hook, so it's the head looker upper doohickey device.
The head looker upper
on sale now for $19.99.
You're gonna get a little competition from the My Pillow guy probably. He'll be like, "Damn it!"
Oh,
Try to
do
steal
not
that
give
idea.
him. Do not even mention to give him any kind of. Nope.
All right, so
we gotta bleep that out.
Okay. So
I
check
don't
out.
think our audience is going to overlap with that audience.
No,
I think we're safe.
No, yeah. Although there's a really interesting dollop podcast on the Pillow Guy, so you can learn a lot of crazy stuff. Anyway, those are the events, celestial events for May, the planets that are up, and the constellation highlight of Corona Borealis. And now it's time for some astronomy news.
Astronomy news.
Astronomy news. All right, this first bit comes from Sky and Telescope magazine. Astronomers find the edge of the Milky Way.
I didn't know it was missing.
Yeah, what happened there? It's like the missing piece.
Yeah. So, okay. So for context, I suppose, spiral galaxies like our Milky Way, they form from the inside outward. So older stars are at the center, younger stars are outward. However, what we found though is that there's apparently a point where that reverses and you get older stars then appearing further out. And so there was a team led by Carl Fitteni, who I guess at the time, and maybe no longer, was at the University of Malta. They analyzed more than 100,000 giant stars, and they did a compilation of observations combined with computer simulations for their studies here. And it showed that this inside-out pattern, so forming from the inside to the outside, it actually reversed 35,000 to 40,000 light years from the center. And that sort of edge, that boundary, that is where stars begin to get older again. And I do have this image here of some data, a graphic of it here. And so this decline in star formation marks the edge of the Milky Way's star-forming disk.
Oh.
So new stars are not being formed outside of this edge that they have found where the older stars begin.
So that's like the farm upstate that stars go to retire.
Pretty much, yeah, exactly. That's
right.
They're out to pasture.
So what's the physics behind that?
All right, well, I'm glad you asked, Mike. Glad you asked. We don't need to drink. It does this every time we come back from me transitioning scenes.
I will just.
You can. Okay, so the analogy presented in the article, it says basically I know we should have somebody that will appreciate this analogy if they listen to this episode. Like surfers carried to the shore, these stars were caught in the spiral waves of our swirling galaxy, which carried them outward and dumped them in the outer regions of the Milky Way. So basically, based on the simulations, the boundary marks a transition that may be a generic feature in pretty much all spiral galaxies. And they're not really sure why star formation drops beyond the galaxies, but these stars had migrated out there. These older stars had migrated out into this area.
From what I understand about like spiral arms, it's not like a wave that's actually carrying. It's just a density wave. It's not actually carrying. Okay. All right. It's not. Just like a water wave doesn't actually carry something.
Mike is upset at this article.
No.
But water waves carry the surfer.
I'm upset at it.
It's a simile. It's like, not an exact. I don't know what I'm talking about either.
Yes, it is a simile.
Well,
it's just trying to give you.
In physics and astronomy, you don't have similes.
But if the galaxy, it's like rotating and there's things moving. It's also kind of like. It's not like it kind of has like a wave to it.
All right.
And so these stars are being carried out somewhere.
Okay, I am not angry at the article, and that's not fair to say. I don't understand the physics and the surfing reference. I'm not completely getting, but
look, I don't know either, man. All I know is, hey, they were like, hey, we found the boundary line where stars stop being young again. Or they just
Which
get
is
they just get
fine.
old.
And I just want to understand the physics, and I guess it maybe makes sense in that the gas that you need to actually form these new stars can only go out so far, and maybe that's kind of where it is. And so yeah.
I don't know. My mom says like centrifugal force. Well, there's
No.
okay, no.
No, I mean that's more of a solid body physics, but
anyway, they still don't know
is.
why star formation drops beyond that boundary, and they maybe don't necessarily know how the stars are ending up there, but somehow they're migrating out there.
I wonder if dark matter might have something to do with it, because you're kind of surrounded by that dark matter sphere, right? I mean, the Milky Way is surrounded by dark matter.
I mean, when in doubt, it's probably dark matter's fault.
I mean, it technically anything that's out of the ordinary when it comes to gravity on these galactic scales, you'd be like, yeah, okay.
We're gonna call that a dark star. We're gonna call that dark galaxy. Matter. We're calling dark, yeah.
All right. Okay, well, maybe you'll like this next article. I don't know.
I did not dislike that article. Oh my, it's so unfair. All right.
Hated it. Astronomers determine brown dwarf age using tiny stellar pulsations. This comes from the W.M. Keck Observatory on Mauna Kea in Hawaii. And researchers used Keck's Observatory Keck Planet Finder, or KPF.
Oh, sounds like a radio station.
I know. Now listening, star pulsations on KPF. So it measured one of the most precise ages yet for a sun-like star hosting a brown dwarf companion. And this allows astronomers to study how brown dwarfs cool and evolve over time. The system is HR 7672. That's the star of it, and so the brown dwarf is HR 7672b, I believe. And that brown dwarf formed alongside the star. So if that brown dwarf, by the way, brown dwarf being a failed star in a sense, it didn't get big enough. It's too big to be a planet, but it didn't get big enough to begin nuclear fusion in its core. So it's kind of it tried to be a star, but then it couldn't hack the pressure. It couldn't handle it, and so it
didn't actually have the pressure.
It didn't have the pressure. Yeah. Which is funny, because if it did, then this would have been just another binary system, that would have formed, but it didn't. And so the age then of the star serves as the benchmark for the brown dwarf companion's evolution. So what the KPF did was it detected subtle oscillations in the star's surface. These are like ripples that revealed its age to be 2.3 billion years old.
So half the age of our sun.
Yeah, and so that, I guess, created the benchmark, and there was an 18% age uncertainty. A quote according to the article: the 18% age uncertainty establishes the HR 7672 system as a valuable benchmark for years to come. And it's a chance to directly test theoretical models of brown dwarf cooling. Now, I got a little confused when I was reading this article. It was a little confusing to understand this whole uncertainty thing. I wasn't sure. But apparently this this KPF thing, machine, whatever it is, it is basically the best thing in the northern hemisphere we have to measure this kind of stuff. It's very can detect,
and it's measuring the ripples on the star,
the pulsations, the subtle oscillations in the star's surface.
That still confuses me.
So it apparently this system.
I haven't read the article, but you're able to go from looking at the subtle pulsations of a star, and you're able to get an age based on that.
So the system has a well-known luminosity and mass, which is what you need to establish age as well. Okay, so according to Yaguang Lee, the lead author and researcher at the University of Hawaii in Manoa, the unique fast readout mode of the Keck Planet Finder makes it the only instrument in the Northern Hemisphere capable of sampling oscillations on such short timescales. And so what they did was they compared the observations with 6 different theoretical cooling models of brown dwarfs.
So that's where they're getting it.
Yeah.
Okay. All right.
And so they found that the best agreement was with the most recent models that incorporate updated interior physics. And the results demonstrate that high precision stellar ages are essential for understanding substellar evolution. So basically, getting precise star ages help to understand things that don't evolve into a star.
Okay. Yeah.
Yeah.
Okay.
Yep.
Yeah.
So
this was basically.
So if this thing looked at our sun, it would get we'd be able to, because we know the mass luminosity of our sun really well.
Yeah.
If we didn't, what are we doing? And so I'm assuming these theoretical models have, worked it out for the sun, and we can test it with the sun.
Yeah, but we don't have a brown dwarf in our system.
No, but it sounds like that the
they need to use it on a system with a brown dwarf to do with the shit that they're doing.
But the oscillation comes from the brown dwarf? It sounded like the oscillations come from the interior of the star.
Yeah, but also it's like super far away and shit. So, they need to test it on something that's an actual I don't know why they do science. I don't know why they... Look, I just pick the articles and I scan through them and then I present them to you for...
I was just trying to understand stuff.
I don't know.
Oh my god!
I don't know.
You can contact Megan O'Shea at moshea@keck.hawaii.edu to answer all your questions.
All right.
There you go.
I might have to do that.
I almost got a picture of it, but I didn't. The KPF. I almost put a picture of the KPF on there. Jack's upset because no one got his Golden Girls reference.
Golden Girls?
And I never...
He said Golden Girls.
I said Golden Girls.
He's not thanking us for being a friend right now.
There you go. I never really watched Golden Girls, so...
It's a fun watch. You should watch it.
I know. I'm aware. I just...
It ages well, just like the Golden Girls.
Hey! Okay. Well, now here's one for you. Astronomers reveal spectacular birthplace of cosmic buckyballs.
Hey!
Buckyballs in space, which every time I say buckyball, my brain just thinks of fucking Bucky from Avengers.
Hi, buddy. Bucky, that's his name.
Yeah, well, I know.
Right?
What's his superhero name?
Yeah, well, he
Captain America's friend.
Yeah.
Winter Soldier.
Winter Soldier. Winter Soldier.
But that's not his Soviet name, is it?
I think it is.
Winter Soldier? Doesn't sound
but with an accent.
That was the movie title. Anyway, I don't know. I just think of that. Okay, so buckyballs are soccer ball shaped molecules that resemble a hollow sphere. They contain 60 perfectly arranged carbon atoms. They were first synthesized
in this particular case.
Well,
you can have, I think you can have more.
Oh, well, that's what it said in this. That they were first synthesized in 1985 at the University of Sussex by Sir Harry Kroto and his colleagues. And he won the 1996 Nobel Prize in Chemistry for it. So he just fucking made some buckyballs. And they were like, here you go. You win. And the name he actually gave it, which I thought this was... I thought this was interesting. The name he gave them was Buckminster Fullerene.
Uh-huh.
Yeah, which was after famed architect Buckminster Fuller, who designed and developed geodesic domes, which have the same structural principle. And I was like, wait, what?
Yeah.
First of all, Buckminster is a name, and the most British name other than Nigel.
Yeah.
Buckminster. It just seems like something like it's like a building in like Westminster, Buckminster.
Well, he did make buildings.
Fullminster, Nearminster. I don't know. Yes. Okay. So Buckyballs for short then, because who wants to say Buckminster Fullerene balls?
Oh, that's fun.
Okay. So here's another little bit where James Webb is at it again. A team led by Jan Kami, or Jan Kami, I don't know, Jan Kami, a physics and astronomy professor, who first detected buckyballs using NASA's Spitzer Space Telescope in 2010. They returned to the same nebula. It was a planetary nebula, TC1, which formed from a dying star more than 10,000 light years away in the constellation of Ara. Which I feel like that's a southern hemisphere constellation, but because it doesn't sound
familiar.
Yeah, familiar. So they imaged this nebula in 2010, but then they went back to it with Webb because Webb clearly has some great imaging capabilities. And this is the image that
why has it got a $sign in the middle of
it? So they were referring to that center kind of little weirdness as an upside down question mark, but yeah, it does actually look kind of like a $sign, or like a letter S. And they don't know what's going on there. They're like, that's weird.
That's where the money's at.
That's where the money's at. That's where the Nobel's at.
I don't have my contacts in, so it's a very fuzzy.
So what this new image revealed to them was delicate rays and all these wispy filaments and like shimmering shells of gas. Very poetic. And it includes not just like this image here, but a lot of spectroscopic data that is basically the chemical fingerprints of like the gas and molecules that are throughout this nebula. And they use a technique known as integral field unit spectroscopy, or IFU spectroscopy, which can measure the temperature, density, chemical composition, and motions of the gas throughout the nebula. And that means it can also measure, they've also been able to basically kind of see, I guess, the three-dimensional distribution of the buckyballs themselves through this new imagery.
Cool.
Physics and astronomy PhD candidate Morgan Geese led the analysis of the C60 emission in this new data, and they found that the buckyballs are not scattered randomly throughout the nebula, but they're concentrated in a thin spherical shell surrounding the central star, or dead star, I guess, in this case. According to postdoctoral researcher Dries van de Putte, discovering buckyballs in space is important because it helps scientists like them track carbon chemistry, explain mysterious signals, and understand how organic materials change in extreme environments. So there you go. James Webb, not just for pretty pictures. It's there for science.
But pretty pictures come out of it.
Yeah, Jack and Shack says the fancy big buckyball is the Epcot sphere.
Yeah,
that's true. Doesn't that, or it used to have a roller coaster inside. Brandon's been to Epcot. Oh my god, it's got Scarlet. What's inside Epcot now?
Right, or it used to be a ride. I think they updated it recently. Not since I have moved. Okay, Scarlet, you gotta move.
You did that to yourself.
I did not actually.
Oh. All right, so buckyballs.
In
space. So thanks, James Webb, for that. All right, now, so far, there's going to be a telescope sent into space that still has funding.
I just see that one.
And it's been unveiled.
And is ahead of schedule.
It's ahead of schedule, which
by
is
8 months.
Which is crazy. Which is crazy because nothing NASA ever does is ahead of schedule or below budget.
They're like, we gotta get this shit up.
They gotta get it. They gotta get it up before funding gets cut. So NASA unveils the Roman telescope to map the universe, and one of its goals is to find 10,000 planets. Exoplanets, yes, because if it's a planet, it's in our solar system. It's got to be an got to clarify, exoplanets. So here is the Nancy Grace Roman telescope right here.
It's also looking at dark matter, right?
Yep, it's going to look at dark matter as well.
That's we talked about it 2 weeks ago.
I think kind of like its primary actually is dark matter. So it's expected to discover tens of thousands of exoplanets and clarify maybe how many could be out there. This is a 39-foot telescope, or 12-meter if you speak science or anywhere else in the world. It has massive solar panels. It's going to be transported to Florida to launch aboard a SpaceX rocket. And September at the earliest is when it's scheduled for launch. It's going to have a field of view that's at least 100 times larger than Hubble.
Okay.
And it's going to be positioned 930,000 miles from Earth. I'm assuming at a Lagrange point.
Yeah, L1, L2.
It's probably one of those ones. According to Mark Melton, a systems engineer at Goddard Space Flight Center, he says, in the first year, we'll have sent down more data than Hubble will have for its entire life.
Oh, shit.
Holy buckyballs, Batman. Like...
It's going to be a lot of research papers off that one.
Oh my god, so many. And yeah, it's also going to study dark matter. That's
L2.
It's at L2. So it's exciting for the Nancy Grace Roman, the NGR Space Telescope, to get out there.
Let's get all that stuff up now.
The more the space telescopes, the better.
Telescopes
be wild. Yes, thank you, Katie. So there you go. So
God, we were so far from where we were just like 50 years ago. You know, with like...
In so many ways.
Yeah, but...
And also so far behind in so many different ways.
You know...
But as far as space science goes, yeah.
Yeah.
We're putting telescopes up above Earth's atmosphere. Mm-hmm. We have developed technology that will warp mirrors here on the ground that basically do a really great job at removing the effects of the atmosphere.
Yeah, because the atmosphere is a bit of a buzzkill for astronomers.
Yeah, and just the computing power, being able to take all the information that telescopes give us and to just, you know, not only download it and make computations with it, but get it to, you know, other scientists in other parts of the world. And it's where are we going to be in 50 years from now? Let's be positive about this. Where are we going to be 50 years from now? Is the question. It's rhetorical.
Well, we'll know what dark matter and dark energy is.
Hopefully.
50 years.
That'd be nice. We have discovered aliens.
Yeah, we'll have sniffed out biosignatures, a different world, for sure, in 50 years.
Enceladus. I'm still hoping there's a big squid in the ocean of Enceladus, or in Europa. We get down there and it just eats the...
So the Europa Report, we want that movie.
That's what I want. I realize it would be millions of dollars lost. But great TV and wow.
Look, I'll be happy if there are xenomorphs out there.
If they're here? If they're here?
If they're out there.
But what if they come here?
Well, you know. Hey, that would just be the perfect way for me
to die. Like I said at the beginning of the episode, this is the last year.
It's the last year. All right. Well, you know what? We still got some groundbreaking astronomical stuff happening, such as DESI. Dark Energy Spectroscopic Instrument. DESI. No relation to Arnez, completes the planned 3D map of the universe and continues exploring.
How many people get the DESI Arnez?
If you don't get a
most
DESI
of our
Arnez
audience
reference, then...
I mean, Jack definitely did with his Shady Pines reference, so he gets DESI.
Yeah. Oh my god.
If Susanna was watching this right now, she would be like, I'm Googling this.
She wouldn't, even if I spelled out like Lucille Ball, she probably wouldn't, you know. It's a Desilu production telescope. No. study by Desilu Productions. Okay, so no,
that's actually funny.
This the DESI has successfully completed the largest high resolution 3D map of the universe ever made. so far. The survey was completed, guess what? Ahead of fucking schedule.
Damn.
Oh my god. And it delivered more data than expected, which this seems not surprising. It's just like with Mars rovers. They last longer and do more shit than anyone ever expects. So I feel like
I wonder in this case if they got more data than expected, if they had to go out and find more budget to store that data. That's a good problem to have.
Maybe. Jack got the Desi joke. All right, we're good. It is a good problem to have. So the Desi collaboration, it has traced dark energy's influence across 11 billion years of the history of the universe. Which is a good chunk of the history of the universe, yeah. I'd say. Dr. Seshadri Nadathur, associate professor at the University of Portsmouth's Institute of Cosmology and Gravitation, who co-chaired DESI's Galaxy and Quasar Clustering Working Group. Cool. Holy shit, man. He says it's hard to overstate how important this DESI map of galaxies will be for cosmology. It's mounted at the Peak National Observatory, down in Tucson, in Arizona, managed by the U.S. Department of Energy's Lawrence Berkeley National Laboratory. And it's collected cosmological data from 6 times as many galaxies and quasars as all previous surveys combined.
Wow.
So a lot of stuff. So now we can expect the first dark energy results from the full 5-year survey that it's completed in 2027. Right now, they're working off of 3 years of survey data. But it has observed more than 47 million galaxies and quasars, plus 20 million stars. And through 2028, the survey will actually grow by about 20% from 14,000 square degrees to 17,000 square degrees in the sky. It's like the amount of sky that it's looking at. Here's an image from the survey showing that structure in there, which
so
is...
you're going to mention this in a second, but it's a big old gap in the center there. We call that, the zone of avoidance is what that's called. And apparently, what's DESI going to do to that zone of avoidance, Liz?
It's going to, that's where it gets closer to the crowded planet of the Milky Way?
Yeah!
Yeah!
Exactly. It's going to decrease that zone of avoidance so we can fill in those gaps.
Okay, I was like, I don't know, I'm not ready for this quiz. Yeah, so they've of course expanded the mission, obviously. So it's gonna take it closer to the crowded planet of the Milky Way, so closing those gaps. It's also gonna revisit previously mapped areas to observe these fainter, more distant galaxies called luminous red galaxies that are kind of a new class of galaxies that we've been able to observe.
Don't know what they are.
And have we first observed them through Webb, I think? Maybe?
I think it was Webb.
Yeah, because Webb can look farther.
All the little red things.
Yeah, and they're like, what the fuck is this shit?
So, Brandon, why do they call it the zone of avoidance?
It's because our telescopes... What was that?
I said that's where the Borg are.
Yeah, we want to avoid that.
Probably.
Definitely always avoid the Borg.
Oh, no, so that's the plane in the Milky Way galaxy, like Liz had mentioned. So currently, we can't see through all the gas and dust and stuff of the Milky Way's plane, so we're left with that big, dark area. Whereas with DESI, we'll decrease that further and further down. Mm-hmm. Which we can guarantee there are just more galaxies out there. It's not actual blank spot.
Yeah.
But if it were,
imagine
the implications.
Just a void. A complete and utter void. Now, okay, speaking of DESI, all right, we got some research already.
More DESI.
We got more DESI. We got research already coming from DESI. So, the title of this article and the previous article in this article, phys.org, in fact, I think all the rest of the articles are from phys.org, said the title was Mapping the Hidden Structure of the Universe. So, Satya Goncho, that's his name, assistant professor in the Department of Astronomy at the University of Virginia, using DESI, has built the largest, DESI built the largest, we'd already talked about that, blah, blah, blah. Basically, using DESI, placed light-emitting galaxies in a 3D relationship with each other, and then astronomers can see the structure on which those galaxies rest.
So I do have to say as well, when I am using our giant 20-meter dome, it's very easy and cool to see that structure of the universe using DESI information. Like, it's really cool to see that come alive.
Yeah. So he says that galaxies are not located at random. They follow a subtle special pattern. They are located on a substructure made of dark matter in the universe. And he is one of 700 scientists from 70 institutions that are currently working on this DESI survey.
Nice.
So, I mean, okay, so in the other DESI article, it said something about like, I think it said even more scientists and more institutions. But I mean, the amount of research that is going to come from just this single, basically, data set, 5-year-long data set survey is going to be absolutely phenomenal. The only thing that sucks about all this is that it takes so long to analyze the data.
There's so much data.
Because there's so much data and there's only so many people.
I wonder who is going to be the first to get the Nobel Prize
from
DESI or from Rubin, because of all the data that comes down.
Fight for the Nobel.
Yeah, I mean, because those are two dark energy.
Yeah.
And I mean, there's going to be Roman up there.
I mean, the question is how many Nobel Prizes are going to be awarded from data using Rubin, DESI, Roman data.
Yeah, I mean, because these are real fundamental. I asked this in full. Honesty is not the right word, but because dark matter and dark energy are fundamental questions of the universe, Nobel Prizes will be given out based on this, and that is going to have to stand on the bedrock, the data bedrock that is Roman, that is DESI, that is Rubin.
And not to mention whatever future technology and telescopes come down the line, assuming we're still here.
Well, Brandon said this is the last year, so
God willing.
God willing.
It's gonna be it's exciting stuff to look forward to really kind of see, okay, what answers we get or what new questions that we get from the answers that we get, or whatever. It could be that maybe there is no dark matter and dark energy, and it's something completely else entirely that we can't even.
Well, I can tell you, it's not mind. I just can tell you right now, it's not mind. Fuck mind. Anyway,
mind.
Modified Newtonian dynamics.
Okay.
You're right. Fuck them.
Yeah.
It's people that are trying to explain dark energy, dark matter by saying that Newton wasn't exactly correct in his formulations, that there's a slight modification to it, which then
I'm gonna go get my pitchfork, because that's not right.
If we've learned anything from maybe some recent news, is that you can do math different ways.
No, you can do math different ways,
you can
but
calculate things.
There's 600% different ways to do math.
It still has to, at no point has Mond been shown to be true.
Mond.
All right. So this next one is just for the beauty of it, really. And that is that Hubble getting still back in the action here. Taking
don't call it a comeback.
It did a new observation of one of my favorite nebulae, the Crab Nebula. Combining this is an image combined with past observations and observations from other telescopes. And really, I mean, the main thing that came out of this was that the filaments of this is a supernova explosion, a star that had gone boom. It was observed in 1034 AD by Chinese astronomers, and the Anastasi, they had also documented it. And so historians, archaeologists, scientists, whoever was able then to actually compare these observations on the opposite side of the world from each other and go, oh, this is the same fucking celestial event. And they determined that it was both civilizations saw the Crab Nebula, this star,
archaeoastronomy.
And they found out that the filaments moving through space at 3.4 million miles per hour.
There's actually a cool video time-lapse video that shows the central part of the Crab Nebula having the gas move out.
Yeah.
And I want to say Jeff Hester was involved.
Yeah, he was involved. So the images that are up right now are a comparison of the 2000 image of the Crab Nebula taken
which he was involved with.
Which Jeff Hester at ASU was involved in using Hubble, and now the image 26 years later with a combination of this image with other images and showing just this more structure, and also you can how the gas they've been able then they could measure the movement of the gases over this 20 some odd year time scale to get the speed at which the gases are moving.
That's super cool.
Yeah.
And
it's super hot.
Yeah, right. We throw the name out Jeff Hester as if like everybody knows who that is.
You should.
You probably don't know the name, but you know the picture.
The
and
pillars of
he's
creation.
A great friend of Corn Dogs as well, as we discovered.
Yes, we did have him on the show.
He's great. He took the picture that is now called the Pillars of Creation.
Of the Eagle Nebula.
It has been turned into a stamp.
Yes. Hubble James Webb took a new picture of it, and it's
beautiful.
So we had I have had the honor of knowing Jeff Hester and interacting with Jeff Hester since I started at a planetarium in 1997.
No.
What is happening?
I've pressed the wrong button.
And then when Liz and Brandon also got to meet him later when they came on, but he's a great guy. Look him up and look up the Pillars of Creation as well. But he wanted to make a planetarium show on the Crab Nebula.
Yeah.
But my best boss of all time was like, no. For whatever reason.
Crab Nebula is really cool.
Oh, look. Booze.
I love the Crab Nebula. Anyway, I just like stars going boom and leaving pretty shit behind.
Yeah.
And then the universe recycling itself because all that material that's made in a supernova meets up with other material from other stars that ejected shit and died and whatever, and then you get fucking planets, and then you get, like shit like us that came from it, which I don't know if that's a good thing or a bad thing, but...
Well, you said shit like us.
Shit like us. That makes sense. And that's how I want to go. Big boom and leave pretty shit behind.
Yeah. Oh, we can all wish. Elvis might have been close.
We're not in a...
Oh, no.
Too soon?
What did you say?
I said Elvis might have been close. Oh. Big boom and leave pretty shit behind.
Yeah.
Right. Cool. Now, okay, people out there, humans of Earth, what have you? If you want to be a scientist, if you want to help out the astronomers, if you want to participate in some scientific astronomical research, guess what? You can. The Euclid Space Warp Citizen Science Project helps hunt for strong gravitational waves.
I'm very tempted.
Okay, so Space Warps, it's a new citizen science project on the Zooniverse platform. So this is where basically regular people like you or I or whoever can just basically join along, and you can help look at data sets based on criteria from astronomers and help find shit. So there's different ones that are out there. This one is for strong gravitational lensing. So the search, so this is using, actually, what they'll be using is images from European Space Agency's Euclid Space Telescope looking for gravitational lensing. And the images have actually not been released to the public yet. And so the people that want to participate in this citizen science project, they actually get a first look at these images before anybody else does. Here is an example right here of Euclid data. So you can see a lot of galaxies here, which is what you're looking at. And then you can see kind of like these streaks of light around these galaxies. And what's happening is you have this larger mass object, like a galaxy, that then has enough mass to bend space-time around it.
That's cool.
And so if there's something behind that object, that light is bent around the foreground object, making it visible. So an invisible object, or an object hidden by an object, becomes visible.
Well, you get the arcs.
Yeah. I mean, you don't see it clearly, but you can see it
Yeah.
in these arcing patterns of the lensing.
Yeah.
So the goal of this is to study dark matter in galaxies, providing clues about dark matter.
That'd be cool.
And so the Euclid Space Telescope, it sends around 100 gigs of data back to Earth every day.
That is insane.
A lot of it. And the Space Warp's team, this new project for the Citizen Science project, will be part of the Euclid Data Release 1, or DR1. And they had 300,000 images that were pre-selected by AI algorithms that were kind of like fine-tuned for this project. There are 72 million galaxies in the DR1 data set.
And they need help looking at them.
And they need help looking at it, because that's a lot of fucking data for a handful of scientists to, do on their own. Jack says in chat, that would be a fun end of year lab for my nerds. Yeah. So this is
Yeah, and frankly, this would be really fun to do in the planetarium with the audience as well.
Oh my god, it totally
What do you guys think? Is there lensing or no?
I know, yeah. Look
and
for
then real
it.
time do that? That'd be fun.
On
my
that would
to-do
really
list.
be fun. I mean, and that would also, that's a great thing for, classrooms and teachers to utilize this, to teach these concepts. According to Aprajita Verma, Space Warp's co-founder and project lead at the University of Oxford, they say, we've already seen the success of combining AI with visual inspection by citizen volunteers and scientists on Space Warps, efficiently finding hundreds of high probability lens candidates in an initial small Euclid search in 2024. So they did like a smaller version of this and found it to be successful, and so now they're making a bigger, larger version of this. So you can Google Zooniverse or Space Warps and see how you can get involved and participate if interested. Or you can also just look at the Zooniverse platform and see what other citizen science projects are on there that you feel like spending some downtime helping out with. You're bored, go do some astronomy.
Or you just don't want to work at your work.
Yeah. Then Zooniverse it up. Dogs.
Zune, come on in, Zune. That's a deep cut for my PBS friends.
Get your dogs involved too. Maybe they want to look for gravitational lensing.
Maybe.
And stuff.
They should. They should want to do that.
I remember when I was like I think when I took astronomy in junior college, or at some point it was like there was something where like there was a citizen science thing where you could help count like craters on the moon.
Oh
yeah.
And identify like the types of craters and stuff, because there's a lot of craters on the moon.
Did you do it?
I know, but we did have a lab. I think that it was like you looked at like a thing and you were
counting craters.
Yeah, and like identifying kind of like the types of craters and stuff.
I remember doing the Zooniverse for planet hunting back in the day, before Kepler was up there. And I probably did over 1,000.
Wow. And I think this is really kind of a really cool thing, and also important because, right, there's only like so many astronomers and various scientists, and they're all working on their own research projects and stuff, but there's also so much fucking data and coming from our telescopes and everything.
And you will on occasion hear about, hey, this supernova was discovered, and it was discovered by somebody in citizen science, or this exoplanet discovered by somebody in analyzing the data in citizen science. So, you actually are going to get credited for it. It's not like the scientist is going to steal your credit. They're going to say, discovered by, Katie Davison, and then
yeah. Unless you're like Vera Rubin or somebody, then.
Well, I'm sure Vera Rubin is also going to get
I'm just saying, she should have got a Nobel Peace Prize. Or Nobel Peace Prize. Nobel Prize. I don't know why I always want to call the Nobel Prize the Nobel Peace Prize. I don't know. Anyway, that is our High in the Sky for May 2026. Sweet. You know, some good news stuff out there. Some fun stuff. You know, the moon's gonna be busy in May, just mooning along throughout the whole month
in May.
So yeah, thanks for joining us, everybody. We encourage you all to go outside, look at the night sky, check out the constellations, make sure that you are, calling your representatives to keep NASA funded, because it's kind of like really important that NASA has money and that we do these things, because yeah.
Especially since the entire National Science Foundation board was just fired, it's important now.
Yeah.
On that note,
hey,
join us in 2 weeks,
where we'll be talking about something
great.
And in the meantime,
we don't want to tell you now, so we'll tell you.
It's so great.
We'll tell you then.
It's so great.
In the meantime, you can check out the shots that come out there. If you got a quick second, you can check those out.
Keep you healthy.
And also check out The Hangover, where we just hang out and ramble after the live show. So you can find those only on YouTube. So hang out for The Hangover.
So we'll see you in 2 weeks.
Yeah. Bye, everybody.
Cheers. Bye.
If you're with us now, stick around. We will be right back for The Hangover. Hangover. Welcome to the Hangover with Cosmos,
Yeah.
where we've gone through the live show and the drinks may or may not be hitting, and we just ramble.
And I just found some gravitational lensing.
Yeah. Yes. If check out our main episode where one of our articles we talked about this Euclid Space Warps program where you can look for gravitational lensing in images of galaxies.
And it's a good thing I did because it was a simulated gravitational lens. So I'm assuming had I failed this, then my responses later on will be less trustworthy.
Ooh.
I put little tests in there, folks.
There you go. Jack in chat asked, so am I going to run into any of you in Japan this summer? No, because we're not going to IPS, International Planetarium Society Conference in Japan.
Yeah, it's in Japan. Yeah.
And
my job doesn't send me anymore.
Yeah, he doesn't get sent to it anymore, so no. But we will be in Philadelphia in July for Doug Institute, and then we will be in Rochester, New York for the Digistar Users Group Conference at Strassenberg Planetarium, where Brandon got passed over for that job for the current director of that planetarium, who's a nice guy.
I'm sure. Just don't ghost people.
We'll give Jim some shit about him taking
completely
Brandon's
not his
job.
fault, but
I wished though we were going to Japan. We had talked about it like last year or something, but it just wasn't going to be feasible.
I probably had the miles for me to go, but I'm trying to get those miles so that you can.
I know we're trying to. We're trying to get the miles so we can go to New Zealand in 2028.
Ah, yes.
That's the goal. New Zealand. So I
can fly. I can fly for free. Trying to get it so that you can fly for free.
Yeah, that would be great. Because that's pricey.
I think at one point I had enough for 4 people to go to New Zealand, but it was shut down because I should take my mom places. Yeah. And turns out that didn't happen because of a variety of different reasons.
Yeah. He's gonna be looking at some the 20K fixer-upper houses. Yeah. Okay.
You have that in Japan? We can move to Japan?
Of course. Yeah, I'm sure we can move to Japan.
20K, let's do it.
Yeah.
That's not even a down payment here in Salt Lake.
Although things are smaller, like the housing, like that just in general, it's just like a small footprint. And
it's
stuff.
Not the U.S. currently.
No, that's true. Do they have universal healthcare in Japan?
I don't know.
They have better healthcare for sure.
They also have, really legit sushi and ramen in Japan. And anime galore. Anime mecca in Japan.
I'm sure living as an expat's a little difficult out there, though. That was one of the things talking to some people in Prague. They go, yeah, no, it's kind of tough living out here as a foreigner. You don't always think about how you would fit in that particular culture in the city.
There are specific, kind of things you have to be aware of to be not offend people.
And to be fair, I was with Mike when this happened, and we were at the bar, and he was like the main guy, and he gave me the worst drink possibly I've ever had in my life. So maybe I don't put too much credence into what he was saying. Oh, buddy.
Yes, Japan has universal health coverage established 1961 and ensures all residents, including citizens and foreign residents, staying for more than a year.
Wow, nice.
Okay.
Free access to providers, low cost, and 30% patient co-payment rate.
I feel like it is one of the it's definitely going to be. It would be a difficult language to learn to write. Speaking it, I have some things just from watching anime, but you have to be very aware of your the formality usage when you're talking to people and making sure you're using the right formal formality things in order to not offend. But I love Japanese culture. I think Japanese culture is really fascinating, and I love the language. I love listening to the language. It's just something that's just very I just love the sound of it.
What's your favorite language to listen to? Is it Japanese?
I would say Japanese. As far as a really foreign language that doesn't resemble English at all. Yeah. definitely Japanese.
I don't know.
Otherwise, like accent-wise, like
Maori and Oaxaca.
If it's like an accent, I think I like like an Irish or a New Zealand accent the most.
Well, New Zealand's not too far from Australia.
I always like going to international airports, especially like outside of Europe, and just hearing all sorts of wild accents and languages. It just makes me happy.
So I was on the phone with this guy from France the other day.
Yeah.
And I just want to go, dude, you're such a cliche. You
know,
it's the accent.
I will say that my least favorite sounding accent is a male French accent.
Well, that's what I had. But I do like the sound of the French language. I mean, it's all one word. Everything blends and all that kind of stuff. I do enjoy an accent from India. It's very sing-songy to me. And I do enjoy it. I don't have the problem with the French accent as like you have, but it is very much a cliche and a stereotype.
I don't know why. I just am like, I'm just like, I don't really care to this accent. I don't care.
But yeah, I like the Irish.
But who knows what the fucking American accent sounds like to foreign ears? You know, I'm sure it sounds just like a weird, bland
one of my favorite things is that Italian song. The guy that tries to simulate what English sounds like to non-English speakers. And the song hits it. Like, it sounds English, but if you listen to it, it's absolutely not. I forget what the song is called. It's on one of the episodes of Ted Lasso as well. But like once every 6 months, it'll get in my head, because even the music video is good. I'll find that right now, actually.
There you go. Yeah, I don't know. I do like accent. I mean, a British accent's always fun. You know, a Scottish brogue.
Well, the British accent, it just sounds refined and intelligent. It might be that they might be
even
saying
if it's
the
a Cockney
dumbest thing in
kind
the
of
world.
like, or a
the refined English. They might be saying the dumbest thing. They might be saying that the world is flat, but it just seems to have a little bit more of a intellectual weight to it. Yes, I can't do an English accent, but yeah.
Oh, Jack knows what he's talking about, what Brandon's talking about, or whichever song he's referencing. Princeton Collinson and Quisol. Jesus, that's a lot. Yeah, see, I feel like the American accent is probably just because it's just like a watered down, I don't know, British accent.
Last refrain.
It's lost its British accentness, and it's just like a bland monotone, just accent. But although I think as far as American accents go, I like a Southern accent just because I like
really. Okay. Well, you're gonna get a handful of it.
It's just a fun one to try and do, because it's probably because it's the most close to the British accent. But yeah,
that's why the accent that the British people always do is Southern.
Yeah. But you know what? But I think like the New Zealand accent, because I'm a big fan watching Xena and Hercules growing up. And so that accent is just like, I like that accent. But
Southern, the accent of racist.
Yeah, well, when we go to South Carolina in a couple months, I'll be working on that Southern accent again.
Oh my god!
Although apparently the Southern accent I do is more Texan, according to Mike. It's more of a Texan.
It's like the type of barbecue sauce, right? What kind of barbecue sauce you making?
Maybe because the Texan one's just a little bit more easy to hit that Southern drawl.
Yeah, they do a lot of drawl
down in Texas,
oh my god,
Georgia.
That's where all my exes live.
You know what doesn't
right, country fans?
You know what doesn't seem like it's a southern state? Florida.
Florida
is like the outlier of all the South.
So northern Florida.
So Florida's flipped around. So Florida, the saying is, the further south you go, the more north you are.
Oh, like northern.
Yeah. So the more north you go, the more southern you are.
Because it's the Panhandle that's in like it's deep south territory.
That's really where like the deep Florida man lives. Is northern Florida.
Yeah. I wonder if that's because Disney has co-opted the rest of Florida.
Well, they've only co-opted the central part. Cuba's co-opted the southern tip.
Oh yeah.
Of Florida with Miami and all that.
Yeah.
And even the east to west coast of Florida is completely different too.
Yeah.
Between the two coasts. I just like the Kennedy Space Center side. I like the Tampa side too. I like most of Florida.
Said few people ever.
I said most, not all.
What's that? There's like on HBO Max. It's the Florida, the thing that we would watch on occasion.
Oh, it was like the Florida things that like only in Florida, or things that happen in Florida, or it's like Florida story. It's like basically just dramatizations, retelling shit that's happened in Florida.
But you know why Florida Man is famous, right? The reason behind it?
No. Is
that Florida releases all their police reports. So anything crazy happening gets automatically released, whereas other states don't do that.
Okay.
So all of crazy is out there on the table for everyone to see.
I still feel
every
like
state's got it.
I still feel like the percentage is probably still higher in Florida.
Yeah,
I agree with you there. I've seen Florida Man; he's real.
Eric says if you go far enough south in Florida, you hit Canada a few months of the year. Not anymore, baby.
Not anymore.
Not for
tourism dollars gone by.
Yeah. Oh, what's crazy though is all the people who get like irritated. Well, people aren't coming to visit the U.S. anymore.
Yeah, no shit.
Well, it's like you shouldn't have voted for that piece of shit.
Why do you think that is?
That's the reason why people aren't coming to this country anymore.
I mean,
but I am keeping things positive this episode. So
is that what we're doing?
I am. Y'all, we can flip rounds we can flip roles if we want. And I'll keep it positive this time around.
No, the person who said this is our last year.
We're gonna stay positive.
We're staying positive.
Yeah.
I was gonna say
we're like the side with the bump in the battery. We're the positive side. Because the flat side's the negative side. The bumpy side is what's that little thing called? That little battery nipple. What's that called?
I think that's the official.
That's the official term now. Is the battery nipple.
Battery nipple.
It's sex positive. The battery nipple.
Give you a little bit of a shock, a little acid taste.
Yeah.
Can you test?
Is it charged?
Like the 9-volt batteries. Oh, is this good? Yep, it's good.
Oh yeah.
You put it in my.
Jack, did the poutine in Florida have like oysters on it? Because maybe that could work. Like a good fried oyster, chopped up on the poutine. I think. Hear me out. I think it could work.
Okay.
That or gator, but gator's way too chewy.
Gator is pretty chewy.
We had gator.
We did have gator in
Papados.
Yeah, Papados. As an appetizer. I'm sure it's like real gator.
I bought gator on the side of the road.
What? Okay, just the look on Brandon's face. All right, gator elitist.
I mean, it's like me saying,
How's that barbecue?
Wait. Yeah, it's like me saying I went to Texas Roadhouse and I got barbecue. I know exactly what barbecue is like.
Where in Phoenix are we supposed to get gator?
I'm not talking about Phoenix. I was talking about when I was in Florida.
That's as close as we could get.
That's as close as we could get. Right, yeah, but we said Papados.
I can see though.
I made a face.
I can see with fried oyster because really with oyster, as long as anytime you have oysters, you're having something on it to give like flavor to it.
There was a place near Titusville. I'm sure it's still open because it never dies down there. They gave you like 20-cent oysters and Varlamus mimosas until the sun rises.
Wow.
And it was beautiful.
Oh my god. I mean, Florida just does what it wants, basically.
Yeah, there are no rules down there.
There's no rules.
Besides the mouse. The mouse is the rules.
And you know what school books are allowed.
I think, if I went to Florida, I think I would do the tourist thing where I would go to Disney Universal in Orlando.
Yeah.
But
I mean, the
I'm sure as hell going to the coast, and we're going to do Kennedy.
Yeah.
Absolutely. Because so Kennedy, they have the space shuttle Atlantis over there, and the introduction to Atlantis is so theatrical and so well fucking done. I've done it probably 80, 90 times. I almost tear up every single time. It's phenomenally done. Because it does the whole introduction.
Yeah, we got teary when we went to LA and saw
Discovery.
Yeah. So one of the cool thing that they do there is there's a theater outside of the main staging area. So they do a little video with really, it's really well done about what are they going to do after Apollo? Like what comes next? No longer is it a camping trip. We're up here to stay in space. So they go through all these different ideations about what the space shuttle could be, different formations of it, until they settle on the traditional look. And so at that point, once they get to where the space shuttle is, they open up another door and you walk into like a smaller theater, but there are like layers to it. There's the main layer and there's like 3 others with all projected screens on it. And they go through a simulated launch and the sound's phenomenal. You get up there and then once you're moving really fast, they pause. And if you're not ready for it, it hits you like, oh, we've stopped. And now it feels like I'm floating. And at that point, they open a transparent screen so you can kind of see behind it. And it's the space shuttle looking right at you. And then the actual screen opens up and they say, welcome home, Atlantis. It's the coolest thing.
Oh, that's neat. I didn't know that was a thing. I didn't know it was there.
No, it's perfect. I wouldn't, no notes, no changes, no notes.
Nice.
Yeah. I would like to see a shuttle again.
Yeah.
Has LA stood theirs up?
They've built they've finished the enclosure building for it. But I don't know if it's in there. Well, they had to have put it in there already, or they had to build it around it, right?
I think it's going to go on boosters, right?
Yeah, it's going to be a whole setup as if it's standing on the pad.
Yeah, so I just read that they finished the building for it, but I don't know if it's actually in there because I would assume they would have to build it around it because otherwise I can't figure out how they would.
And this was years ago they started it, so they're getting close to the end.
Yeah.
And then since I'm on my Florida kick at the moment, once you see Atlantis, they have a life-size model of the Hubble as well. You do all that. And then you walk out of that building, you get on the bus and go on to Kennedy Space Center and go to see the Saturn V that's on its side.
Oh, cool.
And to get into the Saturn V, they take you through mission control that has the actual controls lifted from the original launch site, put into this new place, and they simulate a launch with all these lights and sounds and cameras going on. Again, it's beautiful. So you feel the Saturn V launch in this room with all the original computers, and then you walk through the door, and there's a Saturn V rocket.
That's cool. Can you touch it?
No. I mean, you can jump really high and try to get it. But they do have they do have a moon rock down there you can touch.
You could touch a moon rock?
You can touch a moon rock.
Oh my god.
It's Endeavor in LA. It's not open.
Endeavor. Yeah, I know it's not open yet.
My dad has a picture of me with the Saturn V rocket.
That's cool.
Because we went down to Kennedy
neat.
when I was 3 foot high.
I mean, yeah, I only went to Florida when I was 8 and we went to Disney and Universal. And I got the signatures of all the Ninja Turtles. And
Nice.
the Chipmunks.
As you should.
And some other ones
Yep,
in my
as you
Disney
should.
signature book.
I have a friend in Florida who was an engineer doing his space shuttle days, and they actually took one of the heat shield tiles, and so they just have 2 of those now at the house. They kind of take different schools and show it off. It's the coolest thing.
Those tiles are light.
They're super light.
Yeah, they are not heavy at all.
Well, they gotta be light, right?
Mm-hmm.
Well, I mean, you look at it and you think, hey, it's going on this spaceship. It's going to protect this spaceship. This thing has got to be.
It's got to be 20
duty, right?
Yeah.
Oh, but no, it's very light. So it's really cool.
Man.
Anyway, I can keep talking about Kennedy Space Center. They have a rocket garden. I love a good rocket garden.
I didn't know that I guess I didn't realize there was a whole thing for visitors that you can that the public can just go. I just
Kennedy Space Center, KSC Visitor Center.
I mean, I guess that makes sense that they would have that. I mean, we've been to the center of the universe at JPL, so
yeah, they do a very good job at that.
Chuck says, last week I did an elementary science night and my activity was called Artemis 2.5. I printed a poster of the moon and placed it 6 meters away. I gave the kids a post-it to write what they would have to.
Oh, and then Susanna joins us. Because she
Hi,
asked how the
Susanna.
pod was, and
Hi,
then I was like, "We're in the
Susanna.
hangover now." Hey,
Have
alright.
for the future astronauts to have to live. Okay,
Love
what they
that.
would have for future astronauts to have
Corn
to
dogs,
live. Corn dogs. Like
barbecue sauce.
Depends on the
All
barbecue
right, so
sauce.
let me ask. So you're on the moon. You're in microgravity. You still have, it's what, 1/6 the amount of gravity on the moon?
1/6, so yeah, so it's still
Yeah.
good
So
gravity.
it
you're still gonna
changes.
have. You probably still have issues with crumbs, right? And of course, your taste buds change in space. So what food would you bring with you to the moon?
Well, how do your taste buds change?
So that's why the astronauts up there bring like hot sauce with them. They
Oh,
can't
okay.
taste things as much. It's like COVID light.
Okay, yes.
Well then,
Minus the trash taste,
the
maybe.
CwC vinegar sauce.
Yeah, yeah,
Because I make it hot.
yeah.
Some
And I
like it
guess it
hot.
would be a lot of hot Cheetos and Takis.
Yeah.
Well, not that I've had a Taki,
I
but
think I could be alright.
just slather everything in various sauces and whatever.
Susanna says Skittles.
That's
What
fair.
is then like the change to
Leave
a like a liquid then, like a sauce? Does it
Leave
become
it.
more viscous or less viscous?
Oh, that's a good question. I don't know. There's
Yeah,
still
like,
gravity. There's still
no, but like
gravity.
now just think about the space station, for example. So you spurt water out, becomes, this bulbous bulbs. But at what point do you go bulbous bulbs to just stuff? Like, what's that transition rate? Like, how
Yeah.
thick of a barbecue sauce before it goes into a round ball?
We're on the surface of the moon, right?
But I just asked
but
about
it's
the space
1/6
station.
gravity, so it's
But you can still
Hey,
pour it out.
it just pours a lot slower.
leave it.
Well, the velocity is lower, but it still pours
Leave it.
out.
But it still maintains the same viscosity. I just apparently
Yeah,
like to say the
it's
word
still
viscosity right now.
it's still feeling a gravity,
Mhm,
and what that sauce wants to do is to go to the center of the moon. So it's
Yeah.
still going to
Yeah.
pour down onto your plate, and you can pour milk into your cereal, and that milk is still going to be there.
Right, because there's
That
still
milk,
gravity.
yeah, you pouring the milk or the sauce or whatever, it's not going to have that sauce leave that container at escape velocity and just
Jack says everything pours like 80 times ketchup.
you're right.
You need the knife. You need the knife and a tap on the
Yeah.
Heinz
You
64
got to hit the
Right.
logo.
You gotta hit right on the logo.
You got to hit
That's
the
a C
logo.
spot.
Yeah, so it'll still pour.
Oh, okay. What is the actual plan for a moon base currently? Like a pop-up tent?
Next week.
What are we talking?
Pop-up tent.
It's gonna be-
A Buckful-Meister geodesic dome?
That is actually the easiest one to build, in that or the most structurally
sound and
yeah.
easy.
That's why like all the sci-fi pictures
Uh-huh.
of like space bases and shit, or just like domes and the Buckmeister dome.
So the best, I don't know. One of the more effective ways is, once you build your structures, then to cover it all with regolith to help, sort out all the gamma, the solar rays, for example, so you're not, dead with cancer, because all that regolith will help diffuse that.
Insulate, and Jack says Moonbase by Winnebago.
Lone Star.
That'll be in Spaceballs 2, yeah.
Nice.
Spaceballs 2, the new one. That's the title. Is Spaceballs the new one?
I actually don't know the shape of the structure they intend on building. I know they're going to be landing either by, Starship, SpaceX, or Blue Origin. That tends to put satellites in the wrong orbit.
Well,
I don't know
I tell you what, why don't we just get there first?
Well, yeah. Step 1 is, we've gotten there. Step 2 is landing there.
Yeah, all right. Well,
and then
next
step 3 is like landing and returning home.
And return home. And
return home's the big one.
And then step 4 is do it again multiple times successfully.
What's the base? It's going to be like in orbit or something.
Oh,
like
God.
A space station?
So
like a space station?
No, that's been canceled out probably. But yes, originally there was a moon hab going around the moon, and that would be like the taxi stop. The astronauts stop there first, and they'll go down to the moon.
Mm-hmm.
But as of like 2 months ago, that was slashed.
Yeah, because of just bullshit cuts, or because of logistics?
Because it's probably a good idea not to do that.
Okay.
It's just an extra cost that you don't really need.
Isn't that...
Would a space elevator work better on the moon versus Earth?
Well, for that, we have Red Mars coming up in a couple of weeks.
Yeah.
Oh, is it in a couple weeks that we're going to do this?
I don't know when we're doing that.
Look, honestly, I haven't been reading Red Mars because I've been focused on memorizing lines for a play that I'm in.
And I'm going through my first read-through ever of Path of Kings, Sanderson.
So nobody but me right now is reading Red Mars.
I've read it 3 times.
I've read it this is like...
I've never read it and have just gotten through the first couple chapters, and it's kind of a hard read for me because I'm not finding it that intriguing. And then I started getting involved in this play, and now I have to memorize lines.
So basically...
honestly, me and Mike are just going to not allow anyone to talk during that episode.
Yeah, I figured you guys would carry it anyway, and I'll just say yeah.
So why don't we say in 2 weeks then? All right. Well,
I just said I'm in the middle of a Sanderson book.
We need to also look at the schedule because we might have to rearrange some pod dates based on. Oh wait, no, we don't have a pod. There is supposed to be a pod on one of my show dates. So no, yes, no, just kidding. We're okay. We're good.
All right. Wow.
Oh, the next one's on Mother's Day.
Oh, wait, the next one's on Mother's Day?
Yeah.
Oh, I gotta
Mother's
look
Day.
Time is just really... Oh, Jesus. Time's happening.
Time just keeps on slipping.
God, check out our episode on time for how time works. Jack said the size of the moon depot kept getting smaller, so wasn't surprised that it was cut.
Yeah, it was significantly smaller than the space station, and it only be inhabited for like 4 months out of the year or something like that. And it wasn't the best idea.
I mean, what would be the logistics? I feel like the logistics would be difficult in order to that dock with it and have people.
Yeah, no, it was a bit of a nightmare. But that's I've talked about that in different episodes.
The play that I'm in, Jack, is a local Oak Ridge play, so we got a small theater.
But the title, but the play is not local.
No, the play is called Curtains Up. It's a English-based, London-based play by Peter something.
And I'm basically the understudy of everybody.
He is, because he's
everybody.
But it's basically about 5 women who inherit a play.
Inherit
a theater, a dilapidated theater, and trying to basically work together to try and do a fundraiser to get this theater.
Awesome.
Get funds to get the theater up and running to honor
Liza Minnelli is involved.
Are you finding ways to identify with the character?
Yeah.
Who are you basing it on?
Well, I was trying to use Susanna as a little bit of inspiration because my character, Susanna's younger than this, but my character is a late 20s idealistic woman who inherited this from her father,
who popped off,
who had an untimely death. So there's that background, but Susanna is a very positive, I would say, idealistic young woman in her 20s. So I was like, okay, let me try and channel Susanna's energy and positivity into my character a little bit, because currently I'm just a 40-year-old curmudgeon now that's just pessimistic about everything. So it's trying to be just to have an optimistic outlook on life.
Yeah. At what age do you not become? Are you not optimistic anymore?
I don't know.
4?
Oh gosh, our bandwidth is dropping.
What was the line that you said 2 weeks ago that you kept repeating in the episode? What was it?
Oh, it was okay.
God, what was it?
Now I've forgotten all my lines, Brandon, because you said that one. Oh, officious entanglements.
Oh yeah, that's what it was.
Officious entanglements.
What does officious mean?
Officious
entanglements.
Don't use those big words this early in the morning.
Just showing you my 3 years at university weren't a complete waste. Although we really should change that to 4 years at university.
Yeah, right. We were there for a while.
Whatever.
Remember that one time I was with our former coworker and she calls you over to me and this is awkward, on campus. Don't call Liz over to me. We don't know each other. This is weird.
Yes, at ASU West. I remember that.
Wait
and
a minute.
then look what happened.
All right, Susanna, I will try to be more positive. Wait a minute, I remember this story, but
yeah, so I was taking a bulk of my classes at ASU West for my education classes, and then there was like a little like kind of a convenience store on campus type of
by the stairwell situation.
Yeah, kind of a thing. And so I was in there, and then somebody that worked at the science center saw me, and Brandon was with her, and then so she was like, "Hey," and then it was like this awkward interaction because we didn't really know each other. We just happened to all work at the science center.
And then Brandon was like,
"Was this after you interviewed, or?"
I think this was before that, even
before you interviewed. So we didn't really know each other.
No,
so
I just vaguely knew your face, and why? But the person, she was just like a social butterfly. She just talked to everyone.
Yeah.
And we are each other.
Yeah, so we are not that.
Interview 1 or interview 2?
It's before interview 1.
Okay.
Yeah. And so it was just like an awkward like, oh, hey, and then I didn't know what else to contribute. So that's
cool. I want to leave now.
It was like, okay, and then awesome. Bye.
I'm gonna officiate your wedding one day.
Yeah. Who would have known?
But first, I have to interview for the job.
A couple times.
The first time was the greatest.
Which, okay, I do forever. I'm glad it turned out the way it did, but part of me would have enjoyed being on. Was it D3 or D4 y'all were on at the time?
D3.
I would have loved to be a D3 user.
No, wait, it was after D5 because D3 we went to D5 in 2012.
Yeah, I remember that upgrade period, and that was after my first interview.
Oh.
Yeah.
So whatever was before that
upgrade. 2012. So.
Okay.
But I wish I could say, I was a D3 user.
Yeah, Digistar 3 was such. Oh my god. So, ENS, everybody knows Evan Sutherland did Digistar, right? So it's not like I'm saying anything. So they did Digistar 2. And then Digistar 3 was their first attempt at basically like a full dome system. And even though Digistar 2 is technically a full dome system, but not in a modern sense.
Little different thing, yeah.
Yeah. So there's a whole conversation about that. But anyway, when ENS went from D3 to D4, they basically burned Digistar to the ground and just basically rebuilt it.
But then D4 wasn't actually like very good, right?
No. D4 was
because I get the impression that D4 was kind of like the ugly stepchild after D5 came out. It was kind of like nobody talked about D4 anymore because it was kind of like And D5 incorporated a little bit more of D3, but it was still completely different because we had to redo all of our the amount of time we spent having to fix all of our sources.
Yeah, and then D6.
So much has changed.
Yeah. Oh my god, I can't. Yeah. I have worked on every version of Digistar except for Digistar 1 and Digistar 4.
Mm-hmm. Yeah, because we went from D3 to D5.
Yeah.
I've logged into a Digistar 4 system. Leave it.
But didn't they come out with D4 right after you got D3 and you were like, what the fuck?
For everybody who's not watching this, it's going to be listening to this later on YouTube. They're gonna hear Brandon
Mr. Baggins.
Yeah, something about D4 and just leave it. Don't do D4. I don't know, but now we're on what? Digistar 2026. What are we on now?
Which would technically be D9.
I did find from like 2004, I want to say, the original 2 engineers who made Digistar in 1982 talk for like 2 hours about it on YouTube, and it's really cool. I'll send that your way if you want to have drinks and just listen to them bullshit about Digistar in the 80s. It's a really fun listen. It's a really fun listen.
We looked at a D1 used for a possible replacement, like recently.
When? Yeah.
Okay, cool. I don't even know what to say to that.
Did D2 still have the monkey vomit green wire?
Oh, D1 is going to have monkey vomit green too, because it's all phosphor.
I know that D1 did, but did D2?
Yeah, D2. Yeah, that's
the monkey vomit green.
Yeah.
Okay,
that's
Susanna's asking if anybody needs anything bedazzled. You can contact her on YouTube and then Venmo her for payment on whatever you need bedazzled.
A lot of additional to that question.
Back in the early 2010s for D.
No, but in all seriousness, to promote Susanna there, she did show me some of the stuff that she had done this week alone, and it was freaking amazing.
For bedazzling, yeah.
Bedazzling. And she's actually...
I'm glad bedazzling's making a comeback. I don't know.
Yeah, starring Brendan Fraser.
So, she has asked for our logo.
Oh.
And she's going to bedazzle one for us.
Thank you. I'd like to see it bedazzled. That'd be fun. Like the martini glass could really
I've been trying to take an SVG of our logo and make it to a 3D logo, but I'm having issues finding a solid PNG to make an SVG.
Right. Why don't you ask... Oh, crap. I've just knocked over ourselves. Why don't you ask the person that made the logo for, like, the files on the logo that...
No, I do have those files because you put them on Google Docs and I've been using them. But for whatever reason, Blender is not translating it well, so there are gaps in the SVG.
But I can probably take, like, the original Photoshop file and turn it into, like, an SVG or put it in Illustrator or make an SVG.
Because that way the next time we do a show in the Dome, I'll have the 3D model rotating in the background and make it gold and shiny. It'll look pretty.
Yeah. So, yeah, I can look into that for you based on the actual Photoshop files. I don't think I put the Photoshop files on Google Drive.
I don't think you did, no.
No, I just put the thing. Painting a black hole is too hard, I would say, because you can't... There's nothing to a black hole other than the accretion disk. That's the only thing that we can see.
Well, yeah, but you get the accretion disk from the backside, so you get the whole circle around the black hole.
Wait. What does the backside of a black hole mean?
So if you
which definition do you want?
All right, so if the black hole is here and you're here, and the black hole is in the way, you can't see, like in our everyday experience. Yes. If you're looking at something in the distance, but something is in the foreground, is in the way, you can't see through that something to see what's behind it, right? However, with a black hole, the gravity is so severe that what it does is the light from the accretion disk on the far side, that light goes off in all directions, right? Most of it escapes, you can't see it, but some of it comes pretty close to the black hole. It gets warped around like that gravitational lensing that you were talking about in the main episode, and you see it. And so even though this light originated on the far side of the black hole's accretion disk, you're able to see it. And so that is why when you see that modern picture of a black hole, you see the accretion disk going around it, but then you see the circle. That is the far side accretion disk that you're actually seeing.
Oh, that's okay. Got it.
Well, actually, I was thinking then you can bedazzle a black hole, Susanna, because you can get like black. You can get like a little black sticky jewel thingies, you know, along with the reds and the orangey yellows, and then you have a bedazzled black hole because you can get the shiny black.
Yeah, and so that is that's the reason why you see the circle. You know, black holes are really simple. You've heard me say the accretion disk.
They're the most simplest object that can also melt your brain at the same time.
But like, all right, so when you look at an accretion disk, one of the ways that you can tell if they had a science advisor for the people creating the visuals is you're looking at a black hole, and the material is just going around like this, right? One side of the accretion disk is going to be brighter than the other side. And if you had a science advisor advising the person
Uh-huh.
creating the visuals, the side of the accretion disk where the material is coming towards you is going to be brighter than the other
away.
side. And so if you're looking at a black hole and it's all the same brightness on the accretion disk, they didn't have advisor.
Right.
Which
So if it's
I recall a couple years ago, you gave feedback to somebody about
I
that.
did. I did.
But isn't it better now? Because the brightness is different now.
So, oh God, how do I tell this story?
Don't.
You don't have to. Just say.
You don't have to.
Yeah. We'll just say
or wait for Rochester. How about that? Because I'm sure we'll have planetarium stories in Rochester.
Yeah, it was a great. I just made a comment, and the other person was like, "What?" It was basically like, "What the fuck? What do you mean?"
But the first most accurate portrayal, for lack of a better word, imagery creation of a black hole in media was Interstellar. With Kip Thorne as the science advisor, and they were able to create the most accurate, and that is now what is commonly used as black hole visual to this day.
And then they go off the rails on the story. But...
Yeah, whatever.
I was so mad about that.
Whatever. I weirdly cried throughout that entire movie for no reason. I don't know what was going on with my hormones.
It's emotional.
But I was just like, why am I crying?
So Kip Thorne, for those who don't know, Kip Thorne
has a really cool fucking name for one.
He does.
Not as cool as Rip Torn.
No, but
pretty cool.
Sorry, go ahead.
No, Kip Thorne worked. He was a contemporary with Roger Penrose, who I have met. Stephen Hawking, met his daughter.
Stepped on his grave.
What?
Stepped on his grave.
Yes, we have stepped on his grave, so we were close.
Westminster.
And so Kip Thorne, big general relativity, black holes, gravitational physicist, and he wrote a book. Was it Black Holes and Time Warps or something like that? Black holes, wormhole.
Was it Let's
wormholes,
Do the Time
black
Warp
holes,
again
and time
through
thorps.
A black hole?
That was my drink.
And went on to work on the LIGO project and actually won a Nobel Prize for the discovery of gravitational waves and stuff like that. And so he was a scientific advisor for Interstellar, and so that is why the black hole is so scientifically accurate. And up until then had not been.
No.
But their story advisors were like, I don't know, we're just gonna go artsy with this, and basically fell off. The worst one, or I should say one of the worst ones, is Gravity.
I know you don't like Gravity.
I do not like Gravity
because of their misuse of gravity.
Their misuse of just the science
of inertia and.
I mean. Like, for example,
look, it's entertainment. You gotta have some drama. You gotta have, somebody stranded out there.
No, I get it. It's like The Martian, where It's like The Martians where...
I like the side conversation happening in chat right now.
Right. No, but I agree with Mike, because there are so many things wrong with gravity, including the fact the Hubble and the ISS are completely different orbits.
Like it's a situation that would never have happened to begin with. But also, there wouldn't have been a giant dust storm on Mars that wiped out the entire base, leading to the whole plot point of that movie. So.
But at least he acknowledged that and says, yeah, I know, I had to bend physics for this one thing. Well, whereas gravity was like,
they had to reorient Hubble for gravity to make the fucking movie.
Okay,
don't you want to see Sandra Bullock and George Clooney in a high tense space situation?
I get that. I completely can understand that, and I can now even understand of whatever the fuck happened to it's like 2 satellites or something that collided and blew up or something like that, and that comes through and just shreds the shit out of everything. The first time. The first time.
Hey.
And then what is... Sorry. I'm just going to say unforgivable, which is... It's not unforgivable. It's not at all.
We went in
You
2 different
are-
directions.
is that mission control now says, okay, you have 90 minutes to do whatever because it's going to come back around in 90 minutes, which
But
Are
the
they basing that
speeds.
on they're basing that on what the ISS movement, or
So
not the actual what the inertia would be
right.
of the
So in the movie, ISS, or what is left of it, is going to be moving slowly at its normal pace at this point. But the debris field moves off, goes around the entire Earth, and then comes back around to ISS in 90 minutes. The orbital energy of that would not allow for that debris field to stay in the same.
and it would have spread out.
It would have gone further out because it has
more speed.
more energy.
Yeah, so it would have basically gone out a little bit. Yeah.
There's no way it could stay in the same orbital plane. And not only that, if the Russians had really blown up this satellite, that orbital debris would kind of just stay there. I mean, it would expand out.
Yeah.
But that satellite would have to be so close to ISS for it to shred it like it did.
Hey, you know what we do in the situations?
Nope.
Stop and roll.
Nope. They can. It's just like, it's just such a simple thing. It's such a simple thing. It's such a simple thing. Physics.
That's it.
All right, let's follow up with the conversation that's been happening.
Listen. I just want to know, because I have a lot of questions now.
Wait, for who? For chat? For the
Jack.
Okay. All right. So in chat, this is Planetarium conversation section of the hangover. His school wanted a bunch of options for the A3P ever if they failed, so we send a bunch of them and some to annoy the admin, which appreciated, Jack. You gotta annoy the admin occasionally, and gave specs for 6 velvet projector systems on a 24-foot dome, which is excessive on a 24-foot dome, and they'd have to take out 10 seats to make it fit.
Okay, I see. So it's a star ball. I see.
And now they have an A3P with 2K spherical mirror system.
I appreciate. Oh my goodness, that wait, what? Sorry, I found the A3P in the planetariummuseum.org.
What is who's does the A3P? Spitz?
It's a star ball. Yeah,
it's a Spitz.
Star ball.
Spitz had a star ball?
Yeah.
My goodness, Liz. Spitz was the originator of the mass-produced star ball. That was them.
Really?
Yeah.
It wasn't like Godo or some shit?
Oh, no.
No, Godo does it, and then you had like Zeiss and all that kind of stuff.
Oh, yeah, Zeiss. I feel like
Spitz was the American.
In the 50s and 60s and early 70s, Spitz was doing 1 star ball a week installation in the United States. Like, we got star balls all out there.
Wow. I will say a star ball makes a damn good star field.
Yeah.
But it doesn't do anything other than that.
Nope.
Yeah. So I do love a star ball. There's only one system that does it as good, and that's all I'll say about that. But yeah.
Wait, I don't know if anything can do it as good.
All right.
I have opinions.
The pinpoint.
We'll talk about that in Rochester.
All right,
hold on. Of a star ball.
Hold on.
Oh.
What? Okay, so I think I've missed some stuff, or I haven't read.
What?
I'm a drink and a half in.
Do you need your glasses?
The sphere mirror?
Spherical mirror?
Oh, spherical mirror. Is that what it is?
I'm assuming that's what it means. Jack, you can clarify my interpretation of that.
But he had the second U.S. prototype.
He designed the spherical mirror as the second U.S. prototype for the sphere projector.
All right, so Jack, I think at some point we have to have a conversation about how to get a dome into Oak Ridge. You feel
we have to buy an inflatable dome, is what happens.
Okay, but there is a whole set of expertise right there.
Or we could build a dome ceiling and make it real fucking flush and paint it real fucking light with low reflectivity and project on it.
Like here? Or like
no, not in
no,
not here.
Yeah, so
let's just make a buckyball.
Yeah.
Yeah.
Yeah, I think that actually is a dome type.
I mean, you'll see the seams and shit and whatever, but let's make a
buckyball.
The Oak Ridge buckyball.
The
Bucky Dome.
I mean, Liz and I, we want to, and it's a dream. It's a dream right now to build a planetarium here in Oak Ridge.
Mr. Frodo.
Mr. Frodo, how you doing, Mr. Frodo? You doing better?
He's doing poops are nominal.
Poops are solid and not red. Oh, Bubby. Oh, fuck. Okay.
Yeah. I mean,
all right. We are getting close to outside time.
We are.
Yeah. We want to build a dome here in Oak Ridge. I realize it's a dream, money, but like, how do we get that money? Like today, I was thinking about like, all right, what grants can I go for? Things like that.
That's a great question.
So, you know?
Yeah.
I mean, I know we got to fix projectors for you, so let's see what we can do.
Yeah.
Oh, Godo has a 2-meter buckyball pattern out of cardstock.
Yeah, so you can like get cardboard and make it.
Yeah, I've seen and I have looked up online like how to build a geodesic dome, or they have those like camping domes and stuff, and I was like, ooh, I wonder if we would buy one of those and then make get like a canvas for it or something. But
yeah, I think our thing would have to be that we would have to get the mobile dome and then
a portable dome and
use
that, and then get our money saved from that to then
well, the problem is we have to
fixed dome.
The money we get from that has to pay off the portable dome. Dome first.
Yeah, and then
but I feel like we can get the license to other things pretty easily.
Yeah, so I don't know.
Anyway,
so we are entering the hangover of the hangover.
The hangover, which means it's time
it's breakfast
to
burrito time.
Yeah. Anyway, thanks for joining us.
Shots after this.
Oh God, we gotta record shots. That's right.
Yeah.
Yeah, but you need ball time or something with Mr.
After
Frodo?
Shots, we'll make the shots quick.
No,
well, the shots are
it's
shots.
It's too wet outside. We want to do a ball time. We'll let them out to go use restroom and then wipe them off.
Okay, Jack says the best is use of buckyball frame and negative pressure dome liner to make the sphere. Noted. Thank you, Jack.
We'll talk about that. Thanks, Jack.
We'll talk about that. Anyway, this has been an episode of Hangover where we went from the accents and languages that we enjoy to some space stuff to planetarium stuff. It's been a wide gamut.
We were positive. And we talked about gravity.
We were positive.
Mostly positive.
We were the battery nipple of the episode.
We were battery nipple. I'm never going to look at batteries the same way again.
Meanwhile, Susanna's going to be like, what the fuck?
Thank you all for joining us. Follow us on all the things. Like and subscribe down below.
It really helps with the algorithm. Helps us out.
We will appreciate it. And we will see you next time, everybody.
We will see you tomorrow night.
Sorry.
Bye. Baseball reference.
Live long and prosper. I'm ending the stream. We're ending, and out.
That was fun.
Possibly.